Okay, let's proceed now with our lesson for Module 3 in Pre-Calculus, and that is ellipse. And take note again, ellipse is the third type of the conic section. So for today's competency, we'll have only two. First, we need to illustrate what is an ellipse. So this time we will define the ellipse and its characteristics. And then the second competency is we determine the standard form of the equation of the ellipse. Now, how do we solve or how do we calculate for the standard form of the equation of the ellipse, given that you have the general form of its equation? So by definition, an ellipse is a set of all points in a plane. The sum whose distances from two fixed points is a constant. The fixed points are called the foci of the ellipse. Now, by definition, we mentioned here that this is the sum of distances from two fixed points. Now, for the ellipse, we have the foci. So as you can see on this point, we have the white dot here. This is the first focus. And here we also have the second focus. Now, if you take any point on your ellipse here, so for example, you take a point there or here or this point. Now, the distance from the focus to that point plus the distance between this point and the other focus, the sum of those two distances, that is now the ellipse. Okay, now take note. Again, by definition, the sum of those distances is constant. So meaning, if I take a point here on this part, and you take a point, the distance between the focus and to this point, plus the distance of this point on your ellipse to the other focus, this is still the same as the distance here. Okay, so that is the definition of the ellipse. Now we have here a few characteristics of the ellipse. If you can still remember from our first week's discussion. So an ellipse, if you have here the double nape cone, and then it is intersected by a plane diagonally, it forms a bounded curve. So here you formed a bounded curve that is the ellipse. Now there are two types of ellipse. We have the vertical ellipse and the horizontal ellipse. So this is our vertical ellipse. As you can see here, this longer line is called the major axis, and the shorter line or the shorter axis is called the minor axis. So same on the horizontal ellipse. The major axis is horizontal, the minor axis is vertical. Again, for the vertical ellipse, the major axis is vertical. For the horizontal ellipse, the major axis is horizontal. When we talk about major axis, that is the longest axis on your ellipse. Minor axis is the shorter one. Okay, the endpoints of your major axis, as you can see here, this point, the endpoints of this longest line, nato, is called the vertex or the vertices of your ellipse. We have two vertex here. So we have vertices of the ellipse, and then the endpoints of the minor axis are the co-vertices. And of course, the intersection of the major and the minor axis is called the center. So we will be defining each terms on the next slide. So we have here an ellipse has two axes of symmetry, the major axis and the minor axis. So as mentioned earlier, the major axis is the longer axis and the shorter axis is called the minor axis. So as you can see here, the one in purple or pink rather is the major axis. The one in yellow is the minor axis. So the longer axis is called the major axis and the shorter axis is called the minor axis. So this is an example of a vertical ellipse. Now, the line joining the vertices and the foci is called the major axis or the transverse axis. So another term for major axis is the transverse axis, and the length is 2a. So as you can see here, we have two dots here, the green dots. These are the foci of the ellipse. And take note, by definition, the major axis is the line joining the vertices. So the vertices here are the endpoints of your major axis. You have the vertex on the top portion and another vertex on the lower portion. And then the green dots here are the foci of the ellipse. Now, joining all of these points is called the major or the transverse axis. Now, we also have here a line segment which is perpendicular bisector of the major axis is called the minor axis or the conjugate axis. So perpendicular bisectors, as you can see here, the pink one and the yellow one perpendicular na sila. So we have here the shorter axis, which is in yellow, that is your minor axis, or also known as the conjugate axis. So when I talk about conjugate axis, I am referring to the shorter axis. When I talk about transverse axis, I am referring to the longer axis on your ellipse. Now, the intersection of these two axes is called the center of the ellipse. So as you can see, the intersection of the pink line and the yellow line, you have the blue dot there, which is the center of the ellipse. And also, the center is the midpoint between two foci and the midpoint between two vertices. So meaning, if you try to calculate the midpoint between these green dots here, you will get a value, or you will get the coordinate of the center. Also, if you take the midpoint of these vertices here, which are the endpoints of your major axis, the midpoint there will be the blue dot or the center of your ellipse. Now, another important definition is the line segment through a focus of the ellipse that is perpendicular to the major axis, which is called the latus rectum. So as you can see there, you have your latus rectum. Here, the red one, this is the latus rectum. It is perpendicular to the major axis and of course, passing through the focus. Okay, so looking at this, the latus rectum again is perpendicular to the major axis, but it is parallel to the minor axis. Now, how do we sketch the graph of an ellipse? To sketch the graph of the ellipse, all you need to do is you need to determine the vertices, the endpoints of your minor axis or the co-vertices, and the endpoints of your latus rectum. So the vertices, those are the endpoints of your pink line. The co-vertices, the endpoints of your yellow line. And the endpoints of the latus rectum, that is the endpoint of those red lines. So to sketch the graph of the ellipse, all you need to do is to connect every dots, every points on the ellipse. And around. So from the vertex to the endpoint of your latus rectum to the endpoint of your minor axis, again connected to the other endpoint of your latus rectum, and then your vertex, and then so on. Okay, so you will now form an ellipse. That's how you graph the ellipse. However, based on the competencies I mentioned earlier, we will not be sketching the graph of the ellipse. We will just simply describe the points on the ellipse. So again, the green one, the green dots there are the foci. The blue dot is called the center. The purple, the pink line is the major axis, that is the longest axis on the ellipse. And then the yellow line, which is the shorter axis, is called the minor axis. And lastly, the red broken line there is called the latus rectum. Now we have few properties of the ellipse. The length of the major axis is 2a. So as you can see, the distance from the center to the endpoint, or the distance from the center to one point or one vertex, is a. So meaning, if you take the length of the major axis, that is from one vertex to another, so from the center to one endpoint of your to one endpoint of your major axis, that is A. So in total, you have 2A there. Second, the length of the minor axis is 2B. So from the center to the endpoint of your minor axis, the length is just simply B. That's from the center to one endpoint. That's B. And then you have here from the endpoint, from one endpoint of your minor axis to another endpoint of your minor axis, that's the length now is equal to 2B. You just have to simply add the length of one part of your vertex or your co-vertices. Now, A is the distance from the center to the vertex. So as you can see, as mentioned earlier, A is the distance from the center to the vertex. Again, A is the distance from the center to the vertex. B is the distance from the center to one endpoint of your minor axis or the shorter axis. C is the distance from the center to the focus. Again, let's memorize our notations. A is from center to the vertex. B is from the center to the co-vertex. And C is the distance from the center to the focus. Number 6. The endpoints of the major axis are called the vertices. So as mentioned earlier, endpoints of the longer axis, that's the major axis, that's called the vertex. Now, the endpoints of the minor axis or the shorter axis is called the co-vertices. And then the line segment joining the vertices is called the major axis. This is the red line. The line segment joining the co-vertices is called the minor axis, which is the green line here. Okay, so those are the basic properties of the ellipse. Now we have here our characteristics. So as mentioned earlier, we have two types of ellipse. We have the horizontal ellipse and the vertical ellipse. When we talk about horizontal ellipse, meaning the direction of your major axis is horizontal. When we talk about vertical ellipse, the direction of your major axis or the longest line is vertical. So looking at these two equations, they look almost the same. Almost the same. However, if you try to compare, there is a difference. That's the denominator. Now, for the horizontal ellipse, as you can see here, the denominator of the first component is a squared. The second component denominator is b squared. However, on the vertical ellipse, the denominator of the first component is b squared. And the denominator of the second component is a squared. The first component, I am referring to the x. The second component referring to y. Now take note. A is the distance from the center to the vertex. And B is the distance from the center to the endpoint of the minor axis. Meaning, A is the longest length there comparing to B and to C. Because major axis is the longest axis on your ellipse. So as you can see here, A is greater than B. And to calculate for C, C is simply equal to the square root of A squared minus B squared. Now take note. This is different from the Pythagorean theorem. The Pythagorean theorem is the square root of A squared plus B squared. For the ellipse, C is equal to the square root of A squared minus B squared. Now, how do we identify a horizontal ellipse to a vertical ellipse? All you need to do is you have to check the denominator. Okay, so if the denominator mas dako sa first component, then you'll have the horizontal ellipse. If the denominator on the second component is greater than the denominator on the first component, then you'll have the vertical ellipse. Okay? Sige. So for example, if you have here x minus 1 quantity squared over 16 plus the square of y minus 1 over 4. This is equal to 1. So that's a horizontal ellipse. Why? The denominator on the first component or the denominator of x is greater than the denominator of y. Let me repeat that. If the denominator of x is greater than the denominator of y, then you'll have the horizontal ellipse. But if the denominator of y is greater than the denominator of x, you'll have the vertical ellipse. And then all of these formulas will follow. So we have here vertices. Take note, we have two vertex here. Those are the endpoints of your major axis. So for the horizontal ellipse, you have here the quantity of h plus a and k. Another vertex is the quantity of h minus a and k. Sa foci, we'll have h plus or minus c and k. And then you have here the major axis. Take note, the endpoints of the major axis is the same as the vertices. Let me repeat that. The endpoints of the major axis is the same as the vertices. For the minor axis, this is the co-vertices. So we have here h and k plus or minus b. So again, you'll have two coordinates for the vertex, two coordinates for the foci, and two coordinates for the minor axis. However, on the latus rectum, you'll have four coordinates. One is for h minus k, and h minus c, k plus and minus b squared over a. So here, for h minus c, you already have two endpoints. One for k plus and another one for k minus b squared over a. The other two endpoints of your latus rectum, you'll have h plus c and k plus or minus b squared over a. Okay, and then for the vertical ellipse, these are the formulas. Kindly screenshot this first so that you'll have a record of the list of formulas before we proceed to our examples. Okay, sige, let's proceed with our example. Again, these are the lists of our formulas. Now, for our example, we need to convert the general equation to its standard form. So converting a general equation to its standard form, we'll be using the same process as what we did from the discussion of circle and the ellipse. All you need to do is to group our variables and then factor it out. Now take note. The right-hand side of your ellipse is always equal to 1. Let's go back to the list of our formulas. Look at the equation. The left-hand side, you have two components or two factors. And then the right-hand side, you'll have 1. It is always equal to 1. That's for the ellipse. The right-hand side of the equation should always be equal to 1. Okay, let's proceed. If we have here 9x squared plus 8y squared, this is equal to 288. Now, there's no need for us to factor here on the first two components or the first two factors. Okay? All we need to do is we need to make sure that the right-hand side of the equation is equal to 1. So we multiply both sides of the equation by 1 over 288. So as you can see here, 9x squared over 288 plus 8y squared over 288. This is equal to 288 over 288. Simplify this one. So 9 over 288, you'll get 1 over 32. 8 over 228, or 88 rather, you'll have 1 over 26. Okay, and of course, the right-hand side is equal to 1. So this is now the standard form of the equation of your ellipse. X squared over 32 plus y squared over 26 is equal to 1. Now, what is the direction of your major axis here? Okay, you may type your answers on the chat box. What do you think is this ellipse? Is this a horizontal ellipse or is it a vertical ellipse? Okay, very good. This is a horizontal ellipse because the denominator of x is greater than the denominator of y. Let's go back on our formula earlier. Look at this formula. The denominator of x is a, the denominator of y is b for the horizontal ellipse. And a is greater than b. So this example here is a horizontal ellipse because a squared, which is 32, is greater than b squared, which is 26. Now, suppose I interchange the denominator. This time we'll have x squared over 26 plus y squared over 32 is equal to 1. Then that would be a vertical ellipse because there is a change on the denominator. Okay, so very good. Let's proceed with another example. Let's convert this general equation to its standard form. So we have here 3x squared plus 4y squared plus 24x minus 16y plus 52 is equal to 0. So converting it, all we need to do is we need to regroup first our terms. So as you can see here, we grouped all the x's and we grouped all the y's or all the terms containing the variable y. And this is equal to negative 52. Okay, so we isolate the constant. Next is we make sure that the numerical coefficient of x squared and the numerical coefficient of y squared is equal to 1. So we need to factor out 3 and 4. So factoring 3, you'll have here 3x squared, 3 quantity x squared plus 8x plus 4 quantity y squared minus 4y. This is equal to 52. After factoring we'll have to complete the square. We need to make sure that we add something on our groups to make it a perfect square trinomial. So as you can see here, we added 16 here, and on the y, we added 4 to make it a perfect square trinomial. So since we added 16 and that is multiplied by the factor 3, so you'll have to add it also on the right-hand side of the equation. So that is why you have here 3 times 16. Here, you added 4 times 4, so on the right-hand side, you must also add 4 times 4. So simplifying the equation, you have here negative 52 plus the product of 3 and 16, you'll get 48. The product of 4 and 4, you'll get 16. So we add all these constants here, you get 12. Okay, next thing is we factor out the trinomial. So the factor of this trinomial x squared plus 8x plus 16 is the square of x plus 4. And the factor of this trinomial is the square of y minus 2. Again, we just simply factored out this trinomial. So we have that. Next thing, we make sure that the right-hand side of the equation is equal to 1. So we multiply both sides of the equation by 1 over 12. So you have here 3 quantity, the square of x plus 4 all over 12 plus 4 quantity, the square of y minus 2 all over 12. This is equal to 12 over 12. So simplifying this, 3 over 12, you'll get 1/4. 4 over 12, you'll get 1/3. So you have here the square of x plus 4 over 4 plus the square of y minus 2 over 3 is equal to 1. This is now the standard form of the equation of the ellipse. The question is, what type of ellipse? Is this a horizontal or a vertical ellipse? Okay, very good. This is an example of a horizontal ellipse because the denominator of x is greater than the denominator of y. Okay, let's proceed with the next example. So this time, we will not just simply convert the equation into its standard form. We need to discuss the equation. So when I talk about discussing the equation, we need to identify the necessary points to graph the ellipse. Those are the center, the vertices, the foci, the co-vertices, and the endpoints of our lattice rectum. Now, first things first, given that you have the general form, you need to convert it to its standard form. So here, there's no need for us to factor out. So we'll just have to make sure that the right-hand side of the equation is equal to 1. So we multiply 1 over 144 to both sides of the equation. So multiplying it, you'll have here, simplify 4 over 144. So you'll have x squared over 36. 9y squared over 144, you'll get y squared over 16. And this is equal to 1. Now, if this is the case, we need to identify the value of A, B, C, H, and K. Again, how do we discuss the equation? Given the list of formulas earlier, all you need to do are these 5 numbers. The value of A, the value of B, the value of C, the H, and the K. Sige, so again, A is the greater denominator, B is the lesser denominator, and C is simply the square root of A squared minus B squared. So as you can see here, 36 is A squared, 16 is B squared. So the square root of 36 is 6. The square root of 16 is 4. So you have here A is equal to 6 and B is equal to 4. We cannot interchange these two values because A is always greater than B. Let me repeat that. A is always greater than B. So the greater value is 6, and that would be A. And you'll have here 4 as the remaining denominator. Now, calculating for the value of C, C is equal to the square root of A squared minus B squared. A squared, that is 36, and B squared is 16. So the square root of 36 minus 16, you'll get the square root of 20, which is approximately equal to 4.47. So now we have the value of A, B, and C. How about the value of H and K? Take note, the center has coordinates H, K. So here, what do you think is the center? Okay, very good. The center is at the origin because this is just simply x squared and y squared, meaning the value of H is equal to 0 and the value of K is equal to 0, giving you the center at the origin. So as you can see here, again, what is this equation or what is the type of ellipse? Is it horizontal or is it vertical? Okay, very good. It is still horizontal. So using the equations presented to you earlier, we have all of this. So the center has coordinates HK with coordinates 0, 0 at the origin. The vertices, you'll have here H plus or minus A and K. So again, H is 0, A is 6, B is 4, C is 4.47. All you need to do is to just simply substitute all those 5 numbers here. So H plus A, 0 plus 6, you'll get 6 and 0. That's your H plus A and K. Next, H minus A or 0 minus 6, you'll get negative 6 and 0. So these 2 points are the vertices of your horizontal ellipse. Next, the co-vertices. The coordinates H, K plus and minus B. So again, H is 0, and then your K is 0, plus and minus your B is 4. So you have 0 and 4. Another co-vertex is 0 and negative 4. Now for the foci, we have H plus C, that's 0 plus 4.47. So you have your 0 and 4.47. Another H minus C, that's 0 minus 4.47. Na interchange ini ha. Let me repeat na interchange ini. The foci should be 4.47 and 0. Another, negative 4.47 and 0. Okay, again, there is a typographical error in this part. This is 4.47 and 0, negative 4.47 and 0. Let's proceed with the endpoints of the latera recta. Okay, or the latus rectums. We have 4 endpoints. So these are our equations. So as you can see, H plus C or 0 plus 4.47. So you'll have your 4.47. Next, K plus B squared over A. You can still remember B squared, that is 16. Our A is 6. So 0 plus 16 over 6, you'll get 2.67. Next, the second endpoint is the same, almost the same as the first endpoint. However, this is K minus B squared over A. So you have here 4.47 and negative 2.67. The third endpoint, this time we'll have h minus c. So h is 0 minus our c is 4.47. You'll get negative 4.47 and 2.67. For the fourth endpoint, you'll have h minus c or negative 4.47. K minus b squared over a, you'll get negative 2.67. So those are the 4 endpoints of your latera recta. Now, what is the length of the latus rectum? Okay, so the length of the latus rectum is expressed as 2b squared over a. So 2 times 16 over 6 is equal to 16 over 3 or approximately equal to 5.33. The length of the major axis, that is equal to 2a. So we know that our a is 6. So 2 times 6 is equal to 12. So this is now the length of the longer axis. And then the length of the minor axis is equal to 2b. So 2 times 4, you'll get 8. That is the length of the shorter axis. Again, let's recall the other term for major axis. We call it as transverse axis. The other term for the minor axis is also known as the conjugate axis. Sige. So I want you to try this out. Discuss the equation 4x squared plus y squared plus 24x minus 10y plus 45 is equal to 0. All I want you to do is to convert first this general equation to its standard form and then determine the center, the vertices, the co-vertices, the foci, the endpoints of your latus rectum or the endpoints of the latera recta, the length of the major axis, the length of the minor axis. Okay, so I'll give you maybe 10 minutes to do this activity. So while answering the activity, you may also take your snacks. Okay, so again, the first thing that we need to do is to convert the general equation into its standard form. So here, as you can see, our standard form, the first thing that we need to do is to group our terms having the same variables. So 4x squared plus 24x plus the quantity of y squared minus 10y. This is equal to negative 45. Next is we factor out 4 to make sure that the numerical coefficient of x squared is 1. Next thing is we complete the square. So we need to add something on x and another on y. So we have here 4 times the quantity of x squared plus 6x plus 9 plus the quantity of y squared minus 10y plus 25. This is equal to 45 plus 36 plus 25. So whatever is added on the left-hand side of the equation must be added also on the right-hand side of the equation. So as you can see here, we added 9 multiplied by 4, so you get 36. On the y, we added 25, so there is also 25 on the right-hand side of the equation. Next is we factor out the trinomial. So the factor of x squared plus 6x plus 9 is the square of x plus 3. And then the factor of the trinomial y squared minus 10y plus 25 is equal to the square of y minus 5. And then we simplify the constant. We have here negative 45 plus 36 plus 25, you'll get 16. And then we make sure that the right-hand side of the equation is equal to 1. So you multiply both sides by 1 over 16. And then simplify. So you have the square of x plus 3 over 4 plus the square of y minus 5 over 16 is equal to 1. So do you have the same standard form? Okay, very good. So we have the same answer. Correct. So klaro na to. Next, we need to identify the points. We have our H is -3, our K is 5, our A this time, again, A is always the greater one. So A is equal to the square root of 16, which is equal to 4. And B is equal to the square root of 4, which is 2. And lastly, we have C is equal to the square root of A squared minus B squared. So that is 16 minus 4, you'll get the square root of 12, or approximately 3.46. So if you already have all these 5 points here, all you need to do is to substitute it on our equation. So what is the center? The center has coordinates HK. So you have -3 and 5. But before that, let's identify the type of ellipse. What is the type of ellipse? Is it a horizontal ellipse or a vertical ellipse? Okay, very good. This is a vertical ellipse because the denominator of y is greater than the denominator of x. Next, you have here our vertices, -3 and 9. We also have -3 and 1. The foci, we have -3 and 8.46, -3 and 1.54. Co-vertices, -1 and 5, -5 and 5. Endpoints of the latus rectum or endpoints the latera recta, you have -2 and 1.54, -4 and 1.54, -2 and 8.46. Lastly, this is -4 and 8.46. So did you get all the correct points? Okay, very good. So congratulations, you already mastered calculating or discussing the ellipse. Diba? This is a very easy topic. All you need to do is to just simply identify all these 5 points, A, B, C, H, and K, and then substitute it on the provided list of formulas earlier. So do you have any more questions before we proceed with our activity? Okay, bahala ra na absent sa oras. Ang importante, naka-answer kahit papan. Okay, so since there are no more questions and everything is clear regarding the discussion of our ellipse, let's now proceed with your activity for today. So we have here our activity. All you need to do is to convert the given equation, these equations 1, 2, and 3 into its standard form and identify the following values. So you have H, K, A, B, and C, the center, vertices, foci, co-vertices, endpoints of the latus rectum, the length of the major axis, and the length of the minor axis. And that's the end of our discussion for today's